Welcome back to another exciting episode of Geometry Notes. So we talked about volume of cylinders and prisms in the last section. Now we're going to be talking about volume of pyramids. So a pyramid is a polyhedron. So it's a type of polyhedra, and what we learned in 11.4 is that a polyhedron is a solid shape and all of the sides essentially are flat, doesn't have any curves. So a pyramid is a polyhedron formed by connecting a polygonal base. So connecting a polygonal base to an apex, which is really just kind of a point on top. So here we have these polygonal bases, and they kind of all go up to that apex point, which is the highest point. So the volume of a pyramid is similar to a prism, but instead of base times height, instead of finding the area of the base and just multiplying by the height, it's a third of that, because essentially you've shaved off 2/3 of it to make it come to that point. So the volume of a pyramid is 1/3 your area of the base times the height. So here we have this right prism. It's right. It means it's right if it's straight up and down. This is an oblique pyramid. It's kind of tipped on the side. But same idea remains. You find the area of the base, multiply it by the height on the inside right here. So the height is from that top point straight down, makes a right angle. An oblique one, the height is from the top point, and it still wants to be perpendicular with the base. So I want to find the volume of these pyramids. So the first one, it's a triangular pyramid. We name pyramids based on the shape of their base. So this is a triangular pyramid. So the volume is 1/3 the area of the base times the height. So the area of the base is that triangle right there. Remember, the area of a triangle is 1/2 base times height. So we have 1/2, 4 times 6. 4 times 6 is 24. Half of that is 12. So that is the area of the base. It would be 12 meters squared. And then the height right here in the middle is 9. So you multiply 12 by 9 divided by 3, and you get 36. It's volume, so we want to cube the units. So that's finding the volume of a triangular pyramid. This is a rectangular pyramid. It kind of looks like a square, and it actually is a square because you can see all the dashes, but we don't have a thing called a square pyramid, so we just call it a rectangular pyramid. And the area of that base is length times width, or side times side. They're each 10. So the area of that base is 100. And then the height here, the height is 12. So it can be 1/3 the base times the height. So 1/3 of 100 times 12. Put that all in your calculator. You are going to get 400. And so we're in centimeters and we're doing volume. So it's centimeters cubed. And then this last one is a hexagonal pyramid. Now, it's a regular hexagon. You can kind of see all the sides are the same. And we did in 11.3 the area of regular shapes, but you had to find 1/2 ANS, so the apothem and all that. You could do that in this case, but we only have the side length, so there actually is a formula for the area of a hexagon. And the area of a hexagon is 3√3/2 times the side squared. That would never be a formula I'd want you to memorize, but it's useful in this case. So we have the height, that's the h, and now we can find the area of the base with just the side. So the area of that base is 3√3/2 times, not 10 squared, 12 squared. And you want to put that whole thing into your calculator just as it appears. So you want to do 3√3 divided by, divided by 2 times 10 squared, or you could just do times 100. And that gives us 259.81. That's the base. But remember, the volume is 1/3 the base times the height. So 1/3, 259.81, and the height is 20. Go right back in my calculator, times 20, and I get 5196. Oh, I know what I did wrong. Does anybody see it? I did 10 there by accident when it should be 12, so let's get rid of that. So instead, this should be times 12 squared, and that gives me 374.12. And that's what I'm going to be multiplying by 20 and then dividing by 3. And that gives me 2494.15. And it would be centimeters cubed. So there's finding that base using that formula right there, and then we plug it in. We can kind of apply this. So here we have the actual dimension of a real pyramid. It's the Khafre pyramid. It's a square pyramid specifically. So if you could picture all 4 of those sides being the same. It has a height of 144 meters. At least it originally did. It's a little bit smaller now that it's kind of decayed a little bit. So these are real dimensions. And it has and it gave us the volume in this question. It has a volume of 2,218,800 cubic meters. So I want to find the side length of that square base. It's a square base, so it's the same. So essentially I need to work backwards. So the volume of this pyramid is 1/3 the area of the base times the height. We have the volume. It's 2,218,800. We don't have the base area, but we do have the height, and that is 144. So 1/3 times 144, or 144 divided by 3 is 48. Divide by 48. And the area of the base is 46,225. Now keep in mind, this is a side length that we want. And the area of the base, because it's a square, would be length times width, or side times side, side squared. So how can we undo that? So I just get one side length. You take the square root. So my side length is the square root of 46,225, which is 215 meters exactly. And again, it's side, so it's not squared, it's not cubed, it's a flat length. And that's all because we know that base is going to be s squared. And then we're going to do one of similar pyramids, just like we did with the volume. So you take the volume and you multiply it by that scale factor cubed. Okay? Just like we've done before. So here, your K is your image over your pre-image. So here my image is 8 and 6. Oh, my image is 8. My image is 6. My pre-image is 8. The pre-image volume is 96. So my K is 6 over 8, or 3/4. And to get that volume of pyramid B, I want to take the volume of period A and multiply it by K cubed. So volume of pyramid A, it's 96. K cubed is 3/4 cubed. Make sure you put it in your calculator just like that, because you want to make sure you're cubing the whole fraction, not just the 4 or just the 3. So it would be 96 times 3/4 squared. And that gives, oh, not squared, cubed. That gives me 40.5. And we're still talking volume. And it makes sense, it should be smaller. If the image is smaller, that second volume should be smaller. All right? And now go and watch part 2.